Hello, yes, I'm back with the next part of the ENGAA from 2021. So we're still in section 1, this time part B, Advanced Maths and Advanced Physics, another 20 questions. See how these go. Right, given that y is that, find the value of dy dx when x is a half. Okay, this looks like it could be quite long-winded. I prefer getting these into, indices like that. I just find it less likely I'm going to make a mistake when I go through it. So y dash. So I'm going to have two lots of the differential of the bracket. So that's going to be x to the minus a half, and then that'll be plus a quarter of x to the minus 3 over 2, and then multiplied by the bracket again. Okay, and then I've got to put half into that. Right, that's a bit of a mess, isn't it? So that's going to be 2. This one's flipped, so that would be a root 2. This one's also flipped. So I'm going to have it cubed and rooted, so root 8, so 2 root 2. And then this one's not flipped, so that's 2 over root 2. And then this one is flipped, so root 2 over 2. Okay, so I've now got a 2 root 2. All of those are going to cancel, give me a plus root 2. Then I'm going to have, well, that's root 2 minus root 2 over 2, so that is just root 2 over 2, which is, what is that, 3 root 2 times root 2 divided by 2, that's just 3. So C. Right, that was not an easy opener. Question 22. Point P, mass 2.4 kilograms on a smooth plane inclined at an angle of 60 degrees to the horizontal. Okay, that's 2.4. A constant force of magnitude 2F parallel to the plane applied to P moves up the plane at constant velocity. Right, so we've got 2F there, which is equal to the weight component. Object Q of mass 0.75 kilograms on a smooth horizontal plane. Okay. Constant force of magnitude F parallel to the plane. It moves with constant acceleration. What is the acceleration of Q? Okay, right. So we know then that 2F is going to be equal to, well, a component down the plane. So that is going to be 2.4 times 10, because we're still using 10 here for G. Where was I? Times sine 60, so root 3 over 2. So that means then that F is going to be, I've got 24 divided by 4, so 6 root 3, and then that is going to be the mass times the acceleration that we're after, so 8 root 3. Is that on there? Is it at the bottom? There we go. G. Nice. That was a bit quicker than the last one. Particular arithmetic series, first term A, common difference D. Sum of the first k terms is sk. Which of the following is simplification of Sn plus 1 minus Sn minus 1? So we need to get the n plus 1 and nth terms. That's what we're adding up, really. That's the difference between those two sequences. So for n, that is going to be a plus n minus 1d. And then we need to add on another a, but this time with an nd. So that's 2a plus 2nd minus d. So where's that coming out? G again? Yeah, G. 23 done. 24. Particular sound wave travelling from left to right in air. Distance is labelled as 33 centimetres. That's the speed of sound. What is the frequency of the sound? In which direction has the air at P been displaced from its mean position? Right, well, that second bit's going to be easier. P is nearer to this compression, so it would have moved left. So we know we want something which is moving left. Now we want this speed of sound. So what is our wavelength? Our wavelength, they've given us what, 1, 2.5 wavelengths there. So 5 over 2 wavelengths is going to be 33 centimetres. So a wavelength is going to be 66 over 5 centimetres. Okay, and we want the frequency. So we want 330 divided by our wavelength, so times 5 over 66, but we want to get this into meters. So we're going to want to multiply that by 100 because we divided by centimeters. So that is what, 2500? So, oh, there it is. It's the B, just snuck on the screen already. So 25, how many distinct real solutions are there to this quartic? So what have we got? Well, that factorizes, doesn't it, in 3's and 1's. So we got x plus 3 squared, x plus 1 squared equal 1. So let's see what's happening with the graph then. It's going to be symmetrical about -2. And well, that's all we care about, isn't it? Because it's going to be double root here, double root here. We want to see what it's doing when we're how many times is it crossing? Like, is it doing that? Is it doing that? Is it just touching? So we need to see what's happening there at -2, which is the symmetry point. So if we add that, we would have 4 minus 8 plus 3 all squared. So that is 1. So it just touches there. So we're going to have solution, solution, solution. We're going to have 3 of them, which is D. Right. 26. Resistor R is connected between terminals X and Y. Right, so they're plugging in a resistor there. Power transferred in the 4 ohm heater is 9 watts. So that is going to be our V squared over 4. So the PD across the parallel set then is going to be 6, which means we're getting a fifth. So we need a 2 ohm resistance in total across the parallel set. So that'd be 2 4 ohm resistors. So that is D. Okay. Right, on to 27. The line x equals 1 divides the circle x squared plus y squared is 4 into 2 segments. What's the area of the smaller segment? Okay, so we've got our circle. We're chopping it there. This is at 1. So when we get to this point here, y is going to be what, √3. So we need to chop off that bit, which is going to be, well, if that's √3, that's 1. That must be 60 degrees from our tan. So that's another 60 degrees, which means we're taking a third of the circle. So if I want that area, I've got to take a third of the circle, which is 4 pi over 3. And then I need to take off that triangle. So half base times height, but then I'm doubling it because I've got 2 of those triangles. So it's going to be take off a √3. That's all I've got, isn't it? Yeah. No, it doesn't look like any of those answers. Oh, there's one dropping down the bottom. Excellent, that's a relief, right? H27. And then 28, uniform plank 5 meters. Rest horizontally as shown, pivot 1 meter from the end. Yeah, so they've got that. This is 5 meters, so I can take the top of the screen off. 60 degree cable at the end. Yeah, 75 newtons. It's all in equilibrium. What's the weight of the plank? Right, so we just do moments without the pivot then. So we're going to have 4 times 75 times sine 60 degrees, so √3 over 2. And that is going to be equal to the weight, but the weight is going to be what, 1.5 meters from the pivot, because we've taken 1 meter off the end of the plank. So get rid of that, and then divide that by 3 would make it 25. So we've got 100 √3 is the weight, which is D. Okay. 29. What is the mean of all of these? So I've got to add them up and divide by 3. Right, so if I'm adding those logs, I'm multiplying them together, which doesn't look like much fun. I mean, it makes you think it's probably going to be C, but let's see how we get on. So we're going to have, what we got, 3 cubed. Then I've got to multiply by 64, so that's 2 to the 6. And then 216. So that is, what we got, 72 times 3. Which means we're going to have 3 times 3 times 24. So that's going to be 3 to the 3. And I've still got an 8 left. So 2 to the 3. Right, so it's not C then. Oh, this is a right pain, isn't it? And then, well, I'm dividing by 3. So that'd be like raising the log to the power of a third. So I can cube root all of these. So I'm going to end up with 3 squared and 2 cubed. So 8 times 9 is 72, which is E. Okay. Lorry accelerates along a straight horizontal road with uniform acceleration. Oil droplets from the lorry fall a small distance onto the road at a constant rate. Okay, the time interval between successive trips is T. Right, okay. So we've got 4 successive oil droplets. Right, okay, so we've done that distance X, and then we've done the next distance that they haven't told us, and then we've got, for the third gap, we've got a Y. What expression gives the acceleration for the lorry? Right, okay, so this is all happening at a constant rate. So our change in velocity between each drop is going to be the same, and it's going to be the acceleration times this time t. So we're saying then that the distance x is our average velocity times the time. So let's say it started with v. So for x, we'd have v plus delta v over 2 times t. For y, we're going to have our, well, we've got our v that we've started with, but then we've done 2 delta v's to get to the start of y. And then we'll have another delta v over 2 multiplied by t. And now we want to get a, so we want to get a delta v over t. Now we can see in the answers there's lots of y minus x's, which makes sense because we're going to get rid of those vt's. So if I do y minus x, I'm going to get a vt minus, oh well, plus, I've got to add on the rest of the delta v's yet. I've got what, 5 over 2 delta v times t. And then I need to take off a vt and then take off a half of the delta v times t. So what's that giving me all in all? They're cancelling. So I'm going to have 2 delta v times t. So to get delta v over t, I'm going to have to divide by 2t squared, which is b. Okay, that was quite an interesting question. Something a bit different. Which of the following is the largest in value? All angles are in radians. So we've got cosine of a half, 3/4 and 1, and then sine of a half, 3/4 and 1. Okay, well, all of these are well inside the first quadrant. If you think that pi over 2 is, 1.55 and bits. So it's got to be A or F, definitely on those. So which one is going to be closer to the end? With cos, we're starting here. With sine, we're starting here. So this one, that is closer to 0 than that is to pi over 2. So it's going to have to be A. Right. Light metal wire, length 2.5 meters, cross-sectional area that, suspended. This is going to be, oh yeah, Young's modulus. Here we go. I thought it was going to be resistivity, but it's not Young's modulus. Okay, we're stretching it by that amount. So what do we need? We need to get what Young's modulus is and how much energy is in the wire. So we need an FL over AX for our modulus. So our F is 72. Then our L is 2.5, so I'll write it 5 over 2. And then A is, where are we? 1.8 times 10 to the minus 6. So 9 over 5 times 10 to the minus 6. And then where's the extension? So a half times 10 to the minus 3. So I've got a, what's the things going on here? So it's 36 times 5. And then I've got a 9 over 10, so times 10 over 9 times 10 to the 9. So 4 times 5, so 200, so 2 times 10 to 11. Okay, so that's ruled out these. There's lots of 2 times 10 to the 11s, rather annoyingly. Energy in the wire is a half Fx, so that is 36 times a half times 10 to the minus 3, so it's going to be C. That's the one that's got 18s in it, and it's got to be small, as in it's not that one. So yeah, 18 and then go back 3, so 1 2 3, yeah, definitely C. Okay, 33, we've got a geometric progression. First term is A, common ratio R, sum to infinity, so A over 1 minus R is that. Sum to infinity of the even number terms, okay, is 3/5. So I could say, well, I suppose that's the different, well, the odd number terms would have to be 1 then. So if I started from A and then went 1 over r squared, 1 minus r squared at the bottom, that would have to be equal to 1. So I've got that 5a is equal to 8 minus 8r, and that I've got that a is equal to 1 minus r squared. So 5a is equal to 5 minus 5r squared, which is equal to 8 minus 8r. 5r squared minus 8r plus 3 is 0. Okay, that's gonna split, isn't it, to 5s and 3s. 5r squared minus 5r minus 3r plus 3 is 0. So 5r 1, well, r I mean, minus 1, so that doesn't work. And then I'm going to want to have another r minus 1, so that'll be a minus 1. I need the 3, so yeah, that fits. So I'm going to have that r is going to be 3/5, and that means that a is going to be 1 minus 9 over 25, so that's 16 over 25. Right, what am I doing? A plus r. So I need to add on 3/5 of that. So that is going to be 15 over 25. So 31 over 25. So B. Okay. 34. Child of mass 30 kilograms on a sledge of mass 10 kilograms moving down a smooth slope at 4 meters per second. Okay, so we've got this split 30 and 10, 4 meters per second. This instant, the child jumps backwards off the sledge, lands stationary on a slope. What is the speed of the sledge immediately after the child jumps off? Okay, so conservation of momentum, we've got 4 times 40 is going to equal 10 times v. Is that it? So v is 16. So D. No, I didn't want much for that question. 35. How many distinct points do the following two curves actually meet? Right, okay, so we've got x minus 4. This is going to factorize, isn't it? We're going to have another x minus 4x plus 2. And then for this one, we could have minus, I'll take the minus, what's this? That's just x minus 4 squared, isn't it? X minus 4, x minus 4. Yeah, that would work. So we've got x is equal to 4, or x is equal to minus 3. So C, 2 solutions. Right, they've suddenly gone easy on us. Piece of electrically conducting putty is formed into the shape of a uniform cylinder. The resistance between the ends of the cylinder is R. The same piece of putty is now formed into a new uniform cylinder, half the diameter of the first cylinder. What is the resistance between the ends of the new cylinder? Right, so our resistance is the resistivity times the length over the area. So we've halved the diameter, so the area is now 1/4 of what it was. But the volume is going to be the same, so that means that the length must be times 4, so that the volume is the same. So we've gone up by 16, which is G. Right, another easy one. That suddenly happened with 3 in a row there. Right, evaluate that. Well, that doesn't look very good, does it? So we've got 3's at the top of all of them. We've got 27, 21, 24, 18, 21, 15. Right, so we're dropping in 3. So we've got root 3's at the bottom. So I'll factorize that bit then and see what happens. So I've got 3 over root 3, which would then, if I've got all that outside, I'll have 1 over root 9 plus root 7 plus 1 over root 8 plus root 6 plus plus 1 over root 3 plus 1, or root 1 if I wanted to put it that way. I suppose I'm going to have to rationalise. If I rationalise these, what am I going to get? I'm going to get a root 9 minus root 7 over 2, and then a root 8 minus root 6. So I can see where this is going, because they're all, well, they're not all cancelling, but a lot of them are cancelling. So I'm going to have 9 plus, what do I end up with? What's the last one that I have? I'm going to have a root 3 minus 1. at the end. So I've got root 9 down to root 3, but then I'm taking off root 7 down to 1. So I'm going to have a root 9 plus root 8. Then they all cancel down to a minus root 2 and a minus 1. And then I've got divided by 2 and multiplied by 3 over root 3. Wowzers. Right, so that is 3 minus 1 is 2. And then I've got 2 root 2 minus a root 2. So plus a root 2. Then I need to divide all that by 2. And then I need to multiply by 3 over root 3. Am I getting close to anything yet in the answers? No, I'm not really, am I? I've got, well, actually, well, I could just write that as root 3 on the outside. So is that coming out at 8? Are there any more answers? They don't normally go beyond H. No, they don't. So I've got root 3. Yeah, it does look like H. Root 3, that would be a 1 plus root 2 over 2. Yeah, okay, right, H. That was more involved than the previous 4 put together. Car accelerates from rest in a straight line during the first 10 seconds. Acceleration is that. Okay, as a function of time. Yeah. What is the displacement from its original position after 10 seconds? Right. So our velocity, we just want to integrate these. So 4t minus 0.18 t squared. There would be a constant, but we got v is 0 at t is 0. So integrate again, and then we'll have a 2t squared minus, so I'm going to have to divide this one by 3, 0.06 times t cubed. Again, we've got s is 0 and t is 0, and then we're putting a 10 in. So we'll have 200 minus 1,000 times 0.06, so minus 60. D is 140 meters. 39. PQRS, okay, is a rectangle. P and Q are on the x-axis, Q and R is on the line, x is 15, that's all in the picture, S is on that curve, okay. What's the maximum possible area of the rectangle? Okay, well, it's point S that's moving, so what is our area of the rectangle then? We're going to have, so say S was at xy, then we've got this width here is going to be 15 minus x, and then our y is root x, so that is our area. We want to maximize that, so I'm going to want to differentiate it. So I've got, so let's just write that out as 15 x to the half minus x to the 3 over 2. So dA dx is going to be 15 over 2 x to the minus a half, and then minus 3 over 2 x to the half. I want that to be equal to 0, so let's make those equal to each other, get rid of that, get rid of that, get rid of those, make it a 5, make that an x, x is 5. So if x is 5, I've got 10 times root 5, which is B. Okay, that was a nice question. Now you got one to go, have we? Yeah, it's the last one. 2 trolleys are free to move on a smooth one-dimensional track. Light spring is compressed between the 2 stationary trolleys. The trolleys are released and then separate. Trolleys have mass m and 4m. Okay, spring in between them. The work done by the spring as it expands is W. Assume that no work is done against frictional forces. What's the difference in kinetic energy between the 2 trolleys when the spring has expanded? Okay, so we've got the same force on each trolley. Okay, so this one is going to be accelerating 4 times quicker than this one. And so work done, we want our force times our distance. The distance that they're going to move is going to be, well, we've got is proportional to the acceleration. You know, if you think about S equals ut, that's a half at squared, sad as I am to write out that equation. We've got it proportional to the acceleration. So this one's going to move 4 times further than this one, which means we're going to be doing 4 times the amount of work because they've got the same amount of force. So we're splitting the energy 4 to 1. So, and what do we want to do? The difference in the kinetic energy. So the difference is, if we got 4/5 to 1/5, the difference is going to be 3/5, which is E. Okay, that was quite a nice one to end on. So again, not a bad bunch. I would say, well, there was a couple of sneaky ones. Those last ones weren't too bad considering. That one was quite full on, 37. The otherwise, I had a whole run of really easy ones there, sort of 3/4 of the way through. And I mean, there aren't that many. I mean, 37 was a notable one. 30, I could imagine people getting into a bit of a twist on. Otherwise, they weren't really that bad a bunch, but still quite fun to go through them. But yeah, not like doing pack questions, which are far more enjoyable. But still, there's something to be said for going through these. It can speed things up a bit. Again, it reminds you of getting your number manipulation and your algebraic manipulation, getting those slick, putting in a bit of extra practice, like this one on the logs, wherever the logs was. Where was the log thing? I don't even know where it is now. But there was something about working out logs, wasn't there, where we were working out lots of powers of, this one, here we go. Working out all of these powers, just rattling through those, splitting things out in these numbers, getting the prime factors just to make it easier, multiplying everything together. So yeah, a few bits of tricks like that, and just being slick with your numbers certainly helps on these rapid fire questions. Still, that's done section 1 of the 2021 NJA. So next up will be 2022. I will be doing the section 2 papers as well at some point, even though they've fallen out of favour a little bit, it seems. But yeah, I'll do them at some point because they're more interesting as questions.